The final major cell group that you will see in the dermis are some adipocytes. But in this case, you'll notice that the adipocyte accounts for only around about 5% composition. The epidermal junction, the most common cell, is called a hemidesmosome. What about the epidermis itself? Well, traditional microneedling critics looked at the epidermis and said, too superficial, no burning, no trauma, no blood, no irritation, no patients screaming out of this. So is there value to the epidermis? Because traditionally, the medical market has said, let's just hand this over to the aesthetic market. I don't see value with this. Incorrect. The most dominant cell that you find within the epidermis is the keratinocyte. The keratinocyte is found in basal epidermis, and the keratinocyte accounts for 90 to 95% of cell composition. Vital. The keratinocyte undergoes a process of keratinization, so a fully keratinized keratinocyte then sloughs off as a corneocyte, which is the second most dominant cell that we find within the epidermis. If you have a problem with milia, pathophysiologically, you haven't got a problem with an adipocyte. You've got a problem with a keratinocyte. If you have a problem with acne, you have an issue not with a fibroblast, but you have an issue with the keratinocyte, keratinization, infection, inflammation. If you see hyper or hypopigmentation, your problem's not down here in the hypodermis. Your problem is the failing relationship between the melanocyte and the keratinocyte. The melanocyte is the third most dominant cell that we find within the epidermis, and it resides here in basal epidermis. The melanocyte is a dendritic cell, which is why I draw in these dendrite arms. And the melanocyte accounts for just 3% of cell composition. At 3% cell composition, it's not a lot. However, the melanocyte possesses immense power. Melanogenesis, for a very summarized version. Your melanocyte produces melanin. The melanin in this case is housed in little capsules, and these capsules are called melanosomes. I described the melanocyte. I've never seen a game of baseball in my life. There was 2 seconds of it last night on television before I turned it off, but this is my interpretation. So, in a game of baseball, you have a pitcher, and that's the person who throws the ball, and of course, their arm is important for coordination. This is going to be the melanocyte. So, the pitcher needs to throw that ball and needs to communicate. The ball, in this case, is your pigment, the melanin. This is your melanosome. With this, you're going to need to have a catcher in this baseball game. So with this, if you've ever seen baseball, the catcher does this weird finger thing throughout the game. And the reason why they do that is it's communication with the pitcher. And this is not too dissimilar to melanogenesis. So I want to show with just a little bit of precision here why the world's #1 aesthetic procedure, microdermabrasion, has no long-term effect on hyperpigmentation. When you're targeting corneocytes, but your pathophysiology is the failing relationship between melanocyte and keratinocyte down here, there's no direct cell intervention. Likewise, also, if you are trying to treat post-acne scars, your pathophysiology is fibrotic tissue produced by the fibroblast and irregular collagen, and that's down here. So again, if you treat with microdermabrasion, if you treat with a superficial chemical peel, corneum granulosum, you're nowhere near where the problem is. So with your DP4, we create a direct cell stimulation, and this becomes vital to your procedural success. With this process, although the melanocyte is just 3% of cell composition, the reason why it possesses so much power is its ratio and its handing over of the melanosome. So with this, let's take into consideration that one melanocyte has the capability to throw the ball or to hand over the melanosome to around about 36 keratinocytes. So if one melanocyte malfunctions, it's 36-fold with the keratinocytes. If two melanocytes malfunction, that's 72-fold. So you can see how quickly the melanogenesis process can get out of control, contributing to hyperpigmentation, but also to hypopigmentation. The story develops, however, with this baseball game. It's a traditional game where the pitcher says, "Hi, I'm going to throw the ball. Are you ready to catch?" Then the catcher says, "Yes, I'm ready to catch the ball. Please throw." What about if we put some stress and pressure on the situation and the scenario? So, I'm a baseball player and a pitcher for a baseball company, and I've got to get into the car today to go play my baseball game. Suddenly, my car has run out of battery. I've got to call the company to come fix my car battery. Now, with this, I'm getting into my car, I've got to get to the baseball field. Why am I stopping at every red light, every red light, every red light? I've left my phone at home. Do I go home? Do I go home? Do I go home? I've got lunch at home. Do I bring that? I'm going to head home. Anyway, I'm now running an hour late for the baseball game. The catcher is waiting there. Everyone's sitting there on the baseball field. I'm still not there, and I'm running late. It's an hour and a half. I'm going to quickly get into my baseball gear. I'm running out onto the field now. I've got the ball. Is anyone there? I'm just going to start throwing it. When you create this level of stress and pressure in the body, arguably, in the case for conditions such as melasma, it puts pressure, and this stress now creates an obscene response from both the pituitary gland, which is responsible for the release of melanin-stimulating hormone, but even your melanocyte produces melanin-stimulating hormone. So with this level of stress and pressure, just as you don't perform as efficiently as what you should when you are feeling not yourself, the same thing occurs with your melanocyte and melanogenesis. So we end up with melanin now sitting in the epidermal junction. It's not supposed to be there. And we also see melanin sitting in superficial papillary dermis. It's not supposed to be there either. So what happens in this case is your macrophage identifies the melanin in the epidermal junction and superficial papillary dermis and says, "You're not supposed to be here. This is a pathogen." As such, your macrophage processes this melanin and now becomes a pigment-containing macrophage, and we refer to this as being a melanophage. It's clusters of melanophages that are responsible for dermal hyperpigmented conditions, including dermal and mixed melasma, complications of Addison's disease, but even conditions including erythema dyschromicum perstans, also known as ashidermatosis of Ramirez. So we understand with our view here that if your pigmentation is epidermal, you need to be targeting basal spinosum, but we also see that if your pigmentation is deeper, if it's mixed or dermal, you've got to work deeper. You've got to target the pathophysiology of the cell that's responsible for this malfunction, which is clusters of melanophages. As I map this up, we can now see that, firstly, you need to decide on what your indication is. Secondly, you need to decide on what the pathophysiology is, which cells have gone wrong. Thirdly, we need to determine where they sit within the skin. And now fourthly, we're going to determine what visual endpoint you should be looking for. Because the answer for all of your indications is not arithmetic. The answer for your indications is not mathematics. The answer is actually about what you see, not what you dial up.